Hello and welcome to the 15th IGCSE Maths tutorial, and today we're doing one thing. Geometry! This geometry is actually, I find, quite fun. So, let's get started. We need to start by knowing the fundamental results. Okay. Angles on a straight line always add up to 180. So Z plus R plus H is equal to 180. The angles at a point always add up to 360. A, B, C, D, E. A plus B plus C plus D plus E equals 360. Vertically opposite angles are equal. So you've got two straight lines. You've got A and you've got B. A is equal to B. And you've also got an isosceles triangle always have two parallel sides and two adjacent and two equal angles. All the angles in a triangle, A, B, C, A plus B plus C equals 180. Angles add up to 180. And in a quadrilateral, A plus B plus C plus D, A plus B plus C plus D equals 360. And an equilateral triangle, everything is the same. Okay? So let's find the angles marked with letters. Let's do this one. I'll try to sketch it the best I can. So this is angle F. And we're going to find angle F. We know this angle here is 113. We know this angle here is 80. We know this angle here is 72. So, what formula are we going to use here? We're going to use angle sum in the quadrilateral. Now, you need to know this by heart. So, what we do is we just do 360 minus 60 minus 72 minus 80 minus 113. That gives us an answer for F of 95. Okay? So, our answer for F is going to be 95. F equals 95. Now, polygons. We need to get some more formulas. Okay. The exterior angles in a polygon. First, we need to know exterior angles. Okay. So, this is our closest to regular thing we can get. Closest to regular pentagon that I can get on this. Actually, okay. I'm going to just draw a square on this. Okay. So I'll be back once I've drawn the square. Okay, this is the closest thing to a regular pentagon I can get. I've brought my ruler here. So what we need to do is we know all in the polygon, exterior angles always add up to 360. And exterior angles are these angles, which I'll do in a different color. I've been getting bored of this orange. These are the exterior angles. And they always add up to 360. Now the formula for exterior angles is, since they add up to 360 and there are 5 of them, it's 360 divided by n. Where n is number of sides. Okay. You also need to know the sum of the interior angles of a polygon. Interior angles of the polygon might be this. Let's draw an irregular hexagon, an irregular pentagon. Okay. Whoops about that. Whoops. So interior angles, and these angles, and these angles add up to a certain value, and they are adding up to. They add to n minus 2 times 180 degrees. Okay. And a regular polygon, we'll just draw a square for this one. Just a square. Okay, the square of these. In a regular polygon, all sides and all angles are equal. And we can use this to solve some questions. You also need to know about the angle rules. Okay, we need to start by drawing a set of parallel lines. So one parallel line, two parallel line, and we've got and we're gonna name some angles. This guy. So we've got an angle. This goes on and on and on. We've got angle A. We've got angle B. We've got angle C. We've got angle D. Let's see what now we need to know some things. A is equal to C. C is equal to D. That then tells us that A is equal to D. And the last thing we need to know is B plus C equals 180. That's all you need to know for parallel lines. And you can also use these to find a multitude of problems. The next thing in geometry is the Pythagoras' theorem. Now, you've probably done this before. It's the formula for finding a side on a right-hand triangle. So first we need to draw a right-angled triangle. Bring a pair of sets. Should bring a pair of set squares. But I don't have any set squares. Okay, this is our right-angled triangle. A, B, and C. Now, for any right-angled triangle, and Pythagoras figured this out a very long time ago, A squared plus B squared equals C squared. That's it. That is it. So what you do is you find, that's not what I wanted to do. To draw this out again. Okay, we can also say A squared plus B squared, the square root of all this is equal to C. Good. And this can be used to solve a multitude of problems. There are two types of questions you'll get with this. The first type of question is like this. So this is 4, and this is 3, and yes, you might have seen this one before, because if you it's in the book. Watch the last video. Yes, this is one we did in the last video in mensuration part 2. So it's 4. So what we do is this is A, this is B, and this is C. So we do 4 squared plus 3 squared equals 25. Square root of 25 is then equal to 5. So the side is 5. Another sort of question you might get is this type of question. Need to draw a triangle for this part as well. You also might get this type of question. What? What? Okay, that's better. So they also might give you this question. Say this is 7. This is 6. Find this one. We just need to rearrange our formula to this. So a squared equals c squared minus b squared. This is equal to 49 minus 36, which is then equal to the square root, so that means a is then equal to the square root of 13. And we're just going to leave it like this, because if we solve it, then we get some unintended ugly numbers, because the square root of 13 is an exact answer. Now I'm going to put that in the calculator. I get 3.60555. It goes on forever, and it's just best to keep it as the square root of 13. Unless they ask you to show it to 2 decimal points or 3 significant figures. So let's see how much time we still have time to do symmetry. Okay. Now you have to do this a lot for letters and funny shapes. So let's start with a letter. Okay. A letter B. Okay, perhaps it might be. Okay, let's start with a letter A. I have to do it with my ruler, otherwise it won't be symmetrical. And even then, it's not symmetrical. Something is really wrong with my ruler today, and my pen as well. Okay, so the letter A has one line of line symmetry. It's like this. It's this line. It's this line. Basically, it's like where it reflects on itself. Your face has line symmetry down the middle, but that gradually deteriorates as you get older. Let's think of a shape. For example, a square has... How many lines of symmetry does it have? 1, 2, 3, 4 lines of line symmetry. Line symmetry is pretty easy, and it's all been done before already, pretty much. You also got to know rotational symmetry. How many times it may turn on itself to get the same image. Now, for any regular polygon, it's just its order of rotational symmetry for any regular polygon is equal to the number of sides. We can rotate these 4 times, each at 90 degrees, and we get the set, and the images overlapped on each other because it's regular square. Some shapes only have one line of symmetry. For example, this shape. You have to rotate it on itself 360 degrees, so it is order 1. Also, they also sometimes give you colors. For example, how many lines of symmetry does this have? A rotational symmetry does this have? We can say order 1. Because the orange side means that it won't be exactly the same unless you do it, it won't be exactly the same unless you do it 360 degrees. And, that's about it. So we're on to 4.4, and next time we'll be doing similarity. Okay? So if you've got any questions, don't forget to leave them in the comment section, and, I will answer any questions as soon as I can. But, I guess I'll see you next time in tutorial 16. But for now, I guess I'll see you, later.